All right, so now we're applying law of science to SSA triangles. If you remember back in geometry and when you were trying to prove triangles are congruent, if you recall, SSA or ASS was a postulate that did not prove congruence. You cannot prove triangles congruent by ASS. And this is because even though they give you angle side side, congruent to angle side side, there are technically two triangles that would have those values. So you don't actually know if one triangle is congruent to another because you're not for sure if you have the same triangle or not. The same exact reason for that is the reason why it makes law of science a special case here, because you're not completely sure what triangle you have until you solve. This is what is called the ambiguous case. So here, when you have a angle side side or side side angle, you can still use law of science to solve for it, but this is called the ambiguous case, meaning you do not know what type of triangle you're dealing with until you solve for it. Now, before we get super far, before we start solving this, I want to show you what I'm talking about. So here on this first triangle, we're given values of angle A being 30, angle B, or angle, side B being 9, and side A being 3, or as close to 3 as I can get it, which I can't. It's fine. 3.1, no big deal. Now, without them drawing us this picture, or drawing us a picture and stating it's not drawn to scale, we do not know, just by these values, 39 and 3.1, we would not know that technically these three values don't form a triangle at all. No matter how we swing that 3.1 side, which we can swing it because we don't know what angle C is yet, so we can swing it as much as we want. No matter how we swing it, that side length will never be long enough to create a triangle. So just giving us these three values, we would have to solve to know, okay, yeah, 3.1 is not long enough. This is a no triangle problem. So that's case number one. You could end up with no triangles. Case number two is when you only have one triangle. So if they gave you values, for example, of angle 30, angle A is 30, side B is 9, and side A is 4.5, without solving for this, you wouldn't know, but once you solve for it, you would see that these three values only can form one triangle. They can only form one triangle. So this is case number two, when you could have one triangle. And then finally, case number three is when you have two possible triangles. So you see how that side length A there is swinging from the right to the left. When it's all the way to the right, it creates that huge triangle A, B2, and C, right? You see that? A, B2, and C. That big triangle could be formed. But also, if we close angle C and swing this side inward, it creates a possible second triangle, triangle AB1C. If it just gave us the values of 30, 9, and 5.4, we would have no idea that this could possibly form two triangles. We would have to solve for it and figure out, oh yes, it is two possible triangles. It's ambiguous. It's the ambiguous case. You don't know what triangle is formed. So that being said, what I want to ask, because this is important when solving this problem, what relationship does the right-hand side of B1, so over here, what relationship does that right-hand side of B1, oh, you can't see my pointer at all. No wonder people are confused. Okay, I wish I could write on this. Ooh, I can. Yes. Okay. So I want to let me zoom in. Oh well. So here on this example, um, we have two triangles with B1 forming one of our triangles and B2 forming another. Let me erase this. I didn't realize I was writing. So, what relationship does this angle have with this angle? Yes. Why? How do you know? Oh, well, you don't know that that bottom side is the same, but you do know that this side is 5.4, right? That was side length A. And then we swung side length A inward and got this side length, which is still, whoa, 5.4. So these side lengths are the same. And we learned in geometry that when you have two congruent sides, the angles across from those side lengths are congruent. So that being said, what relationship does this angle have with this angle? If you know that the right-hand side of B1 is equal to B2, what does the left-hand side of B1, what relationship does it have with B2? Yes, Kate. They add up to 180. They add up to 180. Why? How? Yes. How do you know they add up to 180? What does the left-hand side and the right-hand side of B1 form together? Yes, a straight line, a line. And you know that a straight angle is always 180 degrees. It's always 180 degrees. So that means that once you find this angle, say it is 40, right? You do law of sines and you solve for it, it's 40. How would you get this second possible triangle angle right here? What would you do? Yes, 180 minus 40, which is 140. So you're only actually having to fully solve for one triangle. And then once you get that one angle, you subtract it from 180 to get the second one. And we'll do a problem and you'll see exactly what I mean, hopefully. So let's go back to our notes over here. So let's try it. Example number 6. First step, always draw the picture. So it says the measure of angle A is 60 degrees, AB is 30 inches, BC is 27. Find the measure of angle C. So here, this is a triangle, and it says information about triangle ABC. So first step is to draw our triangle, which I'm going to kind of draw mine special so that I can fully show you what's happening here. Let me see here. I'm going to draw this line, and this line. So this is A, B, C. When you're drawing your triangles, you do not need to draw a specific triangle. I just wanted to draw a specific triangle so I can show you clearly what's happening here. All right. So then we put the values it gives us on our triangles. So the measure of angle A is 60, the AB is 30, and BC is 27. Next step is to figure out what type of triangle we have. So here, they give us an angle, they give us a side, and they give us a side. So this is an SSA triangle. Meaning, yes, we can use law of sines, but, so law of sines, but we have to check for the ambiguous case. Which you guys are super lucky because Math Excel will tell you on which type of triangles you need to check for the ambiguous case. If we were in school and just doing like paper homework or a paper test, you would have to just immediately know, oh, this is an SSA. I have to remember to check for the ambiguous case. But Math Excel will tell you that you need to check for it. So that's kind of awesome. All right, so you start solving this the exact same way that we did before. We're trying to solve for the measure of angle C, so that's our x. We put the sine of an angle over the side across from it. So sine of 60 over 27, set equal to sine of the angle we're trying to solve for over the side across from it, 30. And when we cross multiply here, we get sine of x is equal to 30 times sine of 60 divided by 27. And I'm just going to quickly throw that in my calculator. 30 times sine of 60 divided by 27. And we should get 0.96. Now, is this 0.96 what our angle is equal to? No, why not? What do I have to do? Sorry, what's that? What do we have to do? How do we get the angle here? Oh boy. Are people just not wanting to answer, or did people not do their homework yet? How do we solve for a missing angle when using trig? No. Think of it this way. If this had been 2x equals 0.96, how would we get the 2 off of the x? Divide by 10, yes. But do you ever divide by a trig function? What do you write instead? Yes, you have to take the inverse, guys. Whenever you're missing the angle in trig, you should immediately think you have to do inverse trig. That should be like right on the top of your brain when you're thinking about trig. Whenever you're missing the angle, you have to use inverse trig. So here, to get the sine off of the x, I'm going to take the inverse of sine on both sides. Inverse of sine and sine cancel, leaving you with x. And in your calculator, to do inverse, you press second, and then whatever trig function you're dealing with. So in this case, sine. And then I'm not going to type it in 0.96. I'm going to pull what I got previously as an answer. And I love this. Watch this. Watch what happens when I do plug in 0.96. So I'm going to hit second sine, and I'm going to type in 0.96, what I had written down. You get a way different answer. This is a beautiful depiction of why you never type in a rounded decimal in the middle of the problem, because you'll get a super different answer, and all that work you just did on Math Excel is for nothing. You got the whole problem wrong just because you were lazy and you typed in instead of pulling it down. Okay, so 74.21 is our answer. And it's an angle, so you put degrees. Oh, and this is technically not x. This is technically the measure of angle C. Now, how do you bring the whole number down? Oh, I'm so glad you asked. What I do is you hit second sign, but then you want to bring down the whole number, right? You don't want to just type in 0.96. So what you do is you look in your calculator for where you found that answer, and you go up arrow, up arrow, up arrow, up arrow, up arrow until you're highlighted over the part of the problem that you want. Ooh. So I'm highlighted over 0.9622504486. You just press enter and it'll bring it down for you. Enter. Or what you can do instead is, say you got an answer, right? And you do second sign, instead of just hitting up arrow enter, you could just hit second and then see the negative key way down at the bottom. If you hit second, that negative key, that negative sign, it'll say ANS, which just means answer. That is just taking your previous answer and you get the same thing. But I typically just hit up arrow until I've highlighted over what I want it to bring down, and then either way works. All right. So now, remember, this is an SSA triangle. I have no idea if this is my only possible angle. Remember, you could maybe have a second triangle. Remember, we could either have this. So right now, this is what I have. But we also could possibly have this. We need to figure out, are there actually two triangles? So how I do it, remember we talked about it. If I found that this angle C is 74.21, so I'm going to erase this and I'm going to put this actual value here, 74. I could possibly have this regular ABC triangle, which I'm going to call this angle C, C1. Or if I make angle B smaller and swing this 27 inward, you could also possibly have this triangle. Pretend that that 27, I drew the triangle poorly, but pretend that that 27 is just as long as the other 27. So you could possibly also have that second triangle with C2 instead. How do we find this angle? I do know class is over just now, but I'm not done. I just want to get through this. I mean, synchronous time is over. You technically have all of async to still be working on math. So I do apologize for going over, but I think that this is really important for you guys to stay on and watch this. So remember when we were looking at this, once we knew that what B2 was, it was 40, how did we find B1? What did we do? Yeah, same exact thing here. You take 74.21 and you subtract it from 180. So we do 180 minus 74.21. And we get, now same thing, I'm not just going to type in 74.21, I'm going to do 180 minus that whole number. And you get 105.79. So the measure of angle C could also possibly be 105.79. However, technically here, technically you still have no idea if this is a true possible angle. The only thing to know is to now check your answer. So we know for sure that this is a possible answer because when we solved it, our calculator didn't give us an error. If it had said error, it would mean there's no triangles. So we know there's at least one triangle. We need to check for this second triangle. Now, how you do it is what you do is you take the angle measure that you just found and you add it to the other angle measure it gave you, 60. And if this is actually a triangle, these two values need to be what? Yes, less than 180. Can't be equal to 180 because then it would leave absolutely no value, no room for this angle B. It would leave no amount is left over for angle B to be. So it needs to be less than 180 for it to actually be able to form a triangle. So is 105.79 plus 60 less than 180? Does that check out? Yes. So it does mean that you do have two possible triangles. If when you were solving this, say don't write this part. Say instead that you solved this and it had been 165.79. Is 165.79 plus 60 less than 180? No. So what you do is you just don't circle the second one, and this would be a one triangle problem. But we were lucky or unlucky, whatever you want to think, and it did check out. So this is actually a two triangle problem. Any questions here? So again, if when you were solving this first part right here, this first part, and it had given you an error, it would mean you would write there are no triangles. If when you were solving it and you got the second possible triangle, but your check did not work, your two values were not less than 180, it would mean there's only one triangle. If your check works, it means there are two triangles. I am going to record myself doing these other two possibilities. So right now, remember, this example we have is two triangles. I am going to record myself doing two more examples, one for no triangles and one for one triangle. But I am going to let you guys go now. Okay, so now I'm going to do another example. Again, first thing you always do is draw your triangle. So this is again an ABC triangle. Doesn't matter where you put your angles as long as you label them correctly. So C is 89, AC is 34, and AB is 26. So this is an ASS triangle, meaning you can use law of sines, but you have to be wary of the ambiguous case. And we're trying to solve for B, angle B. So you can use law of sines. So we're going to set up our law of sines ratio, which has sine of an angle 89 over the side across from it, which is 26. Set equal to sine of an angle, which we're solving for B. So we put x over the side across from it, 34. Then we cross multiply and we get sine of x is equal to 34 times sine of 89 over 26. That's what I plug into my calculator. I put, whoa, what is happening here? 34 times sine of 89 divided by 26. But remember that this is what sine of x is equal to. To get x by itself, you have to take the inverse of sine on both sides. So I'm going to hit the inverse sine of this. Oh, and it gives you an error. What this means is, whenever it gives you an error like that, either you did something wrong, so you should go back and check this one more time. But if you get an error again, what this means is this is the case where you have no triangles. So this is that GeoGebra, their case here. If we change this A to be this represents the example we just did, where that A length there can't possibly be long enough to create a triangle. So instead we write no triangle. All right, one more example, and then we'll be good, I think. So here, first thing we do, draw our triangle. Again, does not matter how we draw it. A, B, C, as long as we're consistent on how we are labeling. So C is 102, AC is 21, and AB is 24. So here again, notice I have A and a side and a side. So this is an SSA triangle. So I can use law of sines, but I need to be wary of the ambiguous case. Why won't this go away? Okay, so I'm trying to solve for angle B. That's my x. I can use law of sines here, so I'm going to do sine of 102 over the side across from it, which is 24, set equal to sine of x over the side across from it, 21. You cross multiply and solve. So here, sine of x is equal to 21 times sine of 102 over 24. And then remember though that this, once I plug this in the calculator, this, what I will have is sine of x. So you would need to continue and use inverse sine to get what x is actually equal to. So here I do 21 times sine of 102 divided by 24. And then this is what sine of x is equal to. So to get x by itself, you do inverse sine. Anytime you're missing the angle, you have to do inverse function of 8.55, and you get 58.86. So you getting an actual value here means that there is at least one possible triangle. You got to check for the second, but you know there is at least one. 58.86. And this is an angle, so you put degrees. So this is one possible angle measure for B. For sure, this is an answer. But then also, you need to check for the second case, which is where, remember, if we swing this, which side are we swinging here? If we swing this 24, if we change the measure of angle A, we swing this 24 inward, we need to figure out what this B2 right here could possibly be equal to. We find that by taking the angle we just found and subtracting it from 180. So this is the second possible. Why are you being difficult? Second possible triangle, when you take 180 minus the previous angle you found, which was 58.86, and you get 121.14. So the second possible measure of angle B is 121.14 degrees. But we truly don't know if this is a possible unless we check it. So we need to see if this value actually could be an angle in our triangle. We do this by taking the angle we just found and adding it to the original angle it gave us, angle C. These two values added together must be less than 180 for this to actually be a possible triangle. But we can see here 121 plus 102 is going to be way over 180. It's going to be 223 point something, 0.14, which is way over 180. It is not a possible value. It is not an angle measure. So instead, this is only one triangle. The only possible B value is the one that we originally found, 58.86.